Hi, my name is Can Tuzla, and I'm a product manager for Oracle Autonomous Database. As you might already know, Oracle Autonomous Database offers a complete security and networking framework out of the box. In this session, we are going to visit these concepts, see how things work, and more importantly, discover what other options we have, followed by some tips and examples. Let's start.
Before we dive into the nuts and bolts of Autonomous Database when it comes to security and networking, let's do a quick recap of what Autonomous Database really is. Oracle has been investing in automating and optimizing the database for many years, going all the way back to version 9.9. Similarly, database infrastructure has also been in continuous evolution in the past 15 years. Oracle Autonomous Database now completes this journey by combining the infrastructure automation with database automation and adds fully automated data center operations and machine learning. With Autonomous Database, the full database lifecycle management is 100% automated. This eliminates all the complexity, even for mission-critical databases with sensitive data. Therefore, you get to innovate more, pay less, and ensure data safety. When it comes to deploying your Autonomous Database, we offer two options: shared Exadata infrastructure, also known as ADB-S, and dedicated Exadata infrastructure, also known as ADB-D. The primary goal of the shared deployment option is to provide instant ease of use and elasticity. Oracle automates and manages everything, including provisioning, database lifecycle, patches, upgrades, and so on. All you need to do is to choose database compute, storage, and region. That's it. Dedicated deployment option, on the other hand, lets you run your databases on the Exadata infrastructure that's entirely dedicated to you. In that sense, it's your own private cloud. What this brings to the table is customizable isolation at the Exadata, VM, or container database level, and customizable operational policies, such as being able to control upgrade, availability, and resource usage policies. Even though some concepts, features, or capabilities that we are going to talk about might apply to both shared and dedicated deployment options, for the remainder of this session, our main focus will be on Autonomous Database on shared Exadata infrastructure from the security and networking standpoint. These will be the 5 main areas that we will be covering today, namely network access, network encryption, encryption at rest, accessing cloud resources, and user management. Let's start with network access. Autonomous Database offers 3 network access options. First, secure access from everywhere, which is the simplest and easiest network setup option that requires no additional input, as it's the default selection for ADB-S. In this option, the connections go through the internet while still being fully secure and encrypted. Second one is the secure access from trusted clients, in which the connections again move through a public endpoint. However, only the IPs and virtual cloud networks, or VCN, that are specified by the user are allowed to connect to the database. If you are planning to deploy your Autonomous Database on a public endpoint, this is a great option to restrict access to only trusted sources. Last but not least, private endpoints. As you can tell from its name, all network traffic moves through a private endpoint within a VCN in your tenancy. If your organization has strict security mandates that do not allow you to have a public endpoint for your database, this is the option for you. Here is a screenshot from our provisioning flow that lists all 3 options we talked about: secure access from everywhere, secure access from allowed IPs and VCNs only, and lastly, private endpoint access only. Even though the screenshot is from the provisioning flow, the same 3 options are readily available for any existing Autonomous Database. Regardless of which option you choose, Autonomous Database by default uses certificate authentication and TCP/PS protocol with TLS version 1.2, which we will cover in detail later on. Let's take a look at each one of these options in a bit more detail. This diagram shows the network traffic for an Autonomous Database that's on public endpoint with no access control list. Even though the client connections can come from anywhere, all client connections still have to present their SSL certificates to the database to be authenticated. These certificates and keys are stored in a database wallet that users can download. In other words, to be able to connect to your autonomous database, you need not only the database username and password, but also your database wallet. Not to mention, all end-to-end communication between the client and the database is encrypted. Moving on to the secure access from trusted clients with network access control list. Similar to the previous one, this network access option also uses public endpoints. However, just because the database is sitting on a public endpoint doesn't mean that you will be able to connect to it, even if you have the database wallet. As you can see in the diagram, the autonomous database has a network access control list defined in this case. In other words, only the connections from trusted IPs or VCNs are allowed. For any autonomous database deployed on public endpoint, you might want to take advantage of this simple yet powerful feature to further harden the security around your database. Lastly, private endpoints. Let's take a look at these two private endpoint configuration examples. The diagram on the left-hand side shows an autonomous database deployed on private endpoint within my VCN. The connections to the database are made from a VM, which is located in the same VCN, but in a different subnet. Both the VM and autonomous database have their own network security groups, which define the security rules that allow incoming and outgoing traffic. To allow connections from a source with a specific address range, we need to add a stateful ingress rule to the autonomous database's network security group. Similarly, a stateful egress rule is required for the VM to be able to connect to the autonomous database. But what about connecting to your autonomous database from outside of your VCN where it resides? As you can see in the diagram on the right, this is also possible. Even though we are connecting from our on-premises environment, the traffic still never goes over the public internet. To connect from our on-premises data center, we just need to connect the on-premises network to our VCN via Fast Connect and then set up a dynamic routing gateway, also known as DRG. Just like in the previous example, a stateful ingress rule needs to be added to the ADB-S network security group. We have briefly talked about network encryption in the previous section, but now is the time to dig deeper. Just to recap, autonomous database users today have the option to deploy their instances on either public or private endpoints. Whether your connections are made over the public internet or through a VCN, there is one thing in common. They are all secure and use a transport layer security protocol, also known as TLS, with version 1.2. In other words, any communication between the database and the client is encrypted, and both the client and the database can authenticate each other. When it comes to authenticating the client and the server, we have two options. The first option is mutual TLS, or MTLS. In this option, both the client and the server authenticate each other, and ADB-S uses MTLS by default. Since the client credentials are stored in a wallet, as we covered earlier, connections to the database must be made using this wallet. The other option is one-way TLS, or simply TLS. Only the client authenticates server in this option. No wallet downloads, hence no wallet rotations required for JDBC clients. It also offers better connection latency compared to the MTLS. More importantly, it's super easy. Just copy your connect string and connect. Given all these benefits, you might want to check out TLS authentication for your autonomous database if you are using a private endpoint or public endpoint with access control list. Let's walk through an example to see how easily we can start using TLS connections in ADB-S. As we covered earlier, by default, MTLS authentication is required in ADB-S, and only ways to enable TLS in addition to MTLS are either to define an access control list or to use a private endpoint. For this example, we are going to be defining an IP access control rule and unchecking the MTLS requirement so that we can use TLS authentication as well. If you decide to enable TLS authentication for an existing ADB-S instance that's on private endpoint or public endpoint with an access control list, you can do so by editing the MTLS requirement in the ADB-S details page, as you can see as highlighted in this screenshot. The next step is simply to obtain our TLS connect string from the connection strings table, which is located under database connection in the ADB-S details page. Before we move on any further, there are a couple of things to note in this table. Firstly, the table content changes depending on the option you select in the dropdown. If TLS is enabled, the dropdown will have two options, namely TLS and mutual TLS. Since we are interested in establishing a TLS connection, we should select the TLS option in the dropdown and copy one of the connect strings. As the final step, we will connect to our autonomous database via SQL command line, also known as SQL-CL, using the TLS string we copied. That's all. Just to reiterate, we did not have to download or deal with any wallets for this exercise, which is the main highlight of TLS-based connections for JDBC clients. We are also currently working on expanding this great capability to the clients that use Oracle Call Interface as well. In other words, Oracle Call Interface clients will be able to establish TLS connections without a wallet in the near future too. So far, we have covered network access combined with network security. Next, we are going to focus on how things look like for data at rest in terms of security. Autonomous Database stores all the data in encrypted format, and this includes not only data files, but also backups as well. Using AES 256 tablespace encryption, each database and backup has its own encryption key. Additionally, the encryption is always on, meaning it cannot be turned off. Autonomous Database offers two encryption key management options. The first one is Oracle Managed Keys. By default, Autonomous Database creates and manages all the master encryption keys used to protect your data, storing them in a secure key store on the same systems where the database resides. The second option is Customer Managed Keys. If you would like to have the full control of your master encryption keys, you can use Customer Managed Keys via the OCI Vault service. With Customer Managed Keys, you get to control the key lifecycle management operations, such as creating, rotating, disabling, or deleting a key. As we will see in the next slide, the configuration is also pretty simple. Let's take a look at how we can use Customer Managed Keys in Autonomous Database. In order to be able to use Customer Managed Keys, we need to first perform a couple of prerequisite steps. First, we need to create a vault and an AES 256 master encryption key in OCI Vault service. Then, we need to create a dynamic group and a policy so that OCI Identity and Access Management System knows our ADB-S resource has the necessary privileges to access the vault in our tenancy. Just to clarify, a dynamic group is a logical group of OCI resources that you create, while a policy is basically a statement or a list of statements that specify who can access which OCI resources that you have. Below are the sample dynamic group and policy statements. These basically say that my dynamic group, CTUSLA-DG, which includes my autonomous database, is authorized to access the vaults and keys in the compartment called training. In order to use a customer managed key during provisioning, we just need to scroll all the way down on the Create Autonomous Database page and click on Show Advanced Options. Then we need to choose Encrypt using Customer Managed Keys option and select our vault and master encryption key from the dropdowns as shown in the screenshot. But how do we switch to a customer managed key for an existing autonomous database? Well, in order to do that, we need to first navigate to the ADB-S details page as shown in the screenshot. Then we need to click on Manage Encryption Key option under More Actions. Similar to the provisioning example, we again need to choose Encrypt using Customer Managed Keys option and select our vault and master encryption key from the dropdowns. Let's move on to a different topic and talk about how things work when autonomous database needs to communicate with other cloud services or resources, whether it's OCI or a different cloud provider. Autonomous database users often interact with other cloud resources to perform various common operations, such as loading data from object storage or creating an external table. OCI or any other cloud provider needs to authenticate the database before allowing it to perform these operations. You might already be familiar with concepts such as auth tokens, secret access keys, or native authentication. Of course, they all work, but they require multiple steps to create those credential objects, and more importantly, to store them in the database. Now we are going to talk about another alternative authentication method called resource principal, or resource name, or simply principal, depending on the cloud provider. Let's start with OCI resource principal. OCI resource principal is a principal type in Oracle Identity and Access Management that eliminates the need to create and configure OCI user credential objects in the database. To be specific, a resource principal uses a certificate that is frequently refreshed to sign the API calls to certain OCI services, such as object storage or vault service. And the authorization is established through dynamic groups and IAM policies. It's secure and easy, while providing granular control over which services or resources that your autonomous database can access to. As I mentioned, it's super easy to use. All you have to do is to run DBMS Cloud Admin Enable Resource Principal procedure to enable it, and pass OCI $resource principal credential object as your credential name in DBMS Cloud procedures. Autonomous Database also supports using Amazon resource name to access AWS services, such as S3 object storage. Even though the naming sounds a bit different, it's built on top of the same concept, and the same goals and benefits still apply. You just need to configure your trust relationship in AWS and enable AWS ARN in your autonomous database by running the DBMS Cloud Admin Enable AWS ARN procedure. That being said, we will soon be supporting Google Cloud Platform Principal Authentication as well, so stay tuned for that. Let's see how to use OCI Resource Principal with an example. In this example, we will be loading data from object storage into our autonomous database. As we covered earlier, the first step is to create a dynamic group and a policy. The dynamic group and policy statements in this example basically tell OCI IAM that a given autonomous database should be able to read from the object storage buckets and objects that are in the compartment called training. Next, we enable the resource principal in our autonomous database by running the DBMS Cloud Admin Enable Resource Principal procedure. As a last step, we are going to call DBMS Cloud Copy Data procedure to load data from OCI object storage into our table called channels. The important thing to note here is the value of the credential name parameter. When using resource principal, all we have to do is to pass OCI resource principal credential object as our credential name. That's it. It's simple and easy. We don't need to worry about creating and storing individual cloud credentials within the database. Next up, user management. When we talk about security, user management is one of the most important areas that come to mind. Let's see how Autonomous Database handles user management. Autonomous Database comes with a predefined admin user for database management. Admin user has a subset of sysdba privileges, and on top of that, users don't have sys or system access. This is really important because it's how we make sure you get what you need in terms of roles and privileges. Nothing more, nothing less. Hence, each autonomous database can achieve the highest level of isolation without having the risk of stepping on each other's toes. Coming back to the roles, Autonomous Database also offers a predefined role called DW role for data warehousing developers, which includes common developer privileges such as create analytic view, create mining model, create materialize view, so on and so forth. When it comes to user management, database actions is definitely worth a mention. It's a very powerful tool that's available to all autonomous database users out of the box, in which you can load, explore, or model your data, run SQL, manage users, and do many other things. But just to keep in mind, your database roles determine access to these features. When you do user management in database actions, you can grant roles, manage account settings, or enable graph, web access, and OML for your users in a single click without having to type any SQL. It really doesn't get any easier than this, does it? Let's move on to user authorization and authentication. We briefly touch base on managing users who are accessing the database and controlling what operations they can perform. Everything we talked about user management so far was through local authorization and authentication, in which the autonomous database provides password-based authentication as well as authorization through roles and privileges. Similarly, secure password properties and complexity rules are also provided by the autonomous database out of the box through predefined user profiles. However, if you'd like to centrally manage your users outside of your autonomous database, you can do so by using Microsoft Active Directory today. Microsoft Active Directory basically provides centralized authentication and authorization of users. Not to mention, you can easily associate your AD users with the database users and roles. In addition, Autonomous Database honors all AD account policies as well. Connecting to your autonomous database using Microsoft AD is almost identical to traditional database connections as well. You just specify your AD domain and username within double quotes, along with your password and TNS alias. That's it. As an alternative to Microsoft AD, we will soon be introducing a centralized user management through OCI IAM as well, which is aimed towards the same goals, benefits, and ease of use. You might want to be on the lookout for that one as well. In this session, we have covered some important concepts, features, and tips about autonomous database in terms of security and networking. Hope you have found it useful. If you would like to learn more about autonomous database, please make sure to check out the links below to our blogs, ADB homepage, and documentation. And if you still haven't tried Autonomous Database or Oracle Cloud yet, I highly recommend getting started with our Always Free tier that you can use for an unlimited time and 30-day free trial that gives you free credits for various OCI services. Thanks for tuning in.